Okay, for this one we're going to take a look at problem 30 out of the book, which is finding the horizontal tangent line, that thing right there. I just wanted to highlight the problem so we know what we're looking at. Let me get rid of that highlight so we can actually read the problem. It says, at what point is the tangent to f of x equals 3 minus 4x minus x squared horizontal? So the difference between this problem and any other tangent problem that we've had is that with this problem, we don't know what x is. We are looking for x. But everything else is still going to stay the same. We're still going to be doing the limit as h approaches 0 because we're still talking about the slope. The limit as h approaches 0 of f of a plus h minus f of a all over h. Now normally we're working that through and trying to figure out what that equals. In this problem, we know what that equals. We know what that slope is. We're told about the slope. It says that we want the tangent line to be horizontal, which is, now you can't see that because I just highlighted over it, so let's get rid of it. See, it says horizontal. So horizontal lines have a certain slope. Their slope is 0. So I want this limit to equal, we don't want the highlighter, we want the actual marker, we want this to equal 0. So we're going to go through this process doing the limit where a stays a. No problem. So I still have the limit as h approaches 0. F of a plus h, it's going to get real big. F of a plus h means plug a plus h into that entire function. So 3 minus 4 times x. Well, what is x? X is a plus h. Minus x squared. Well, what is x? X is a plus h. All of that is just this portion, f of a plus h. That's all that this is. I have to keep going with the rest of it, minus f of a. I'm going to put that in parentheses, and I hope it'll fit. F of a is just replace all of the x's with an a, so this will be 3 minus 4a minus a squared. Just got it to fit. What that is this piece. It's important that we realize what is what. And then we have h on the bottom. Okay? It looks nasty, it looks ugly, it's big, there's a lot of stuff, a lot of pieces to this. Now we just have to make sure our algebra is good, because right now you plug in 0, 3 minus 3 is going to be 0, you're going to end up with just minus 4a, minus a negative 4a, that's 0. You get negative h squared, negative a squared, excuse me, minus a negative a squared, which is also 0. So you end up with 0 in the numerator and 0 in the denominator. That's not going to work. We can't evaluate that, so we have to mess around with it. And messing around with it means expanding this whole thing out. So I'm going to shortcut this. I'm just going to expand it all out. And your algebra skills have to be good. You have to distribute the negative 4 to the a plus h. You have to distribute this negative sign. This negative sign right here, you have to make sure you distribute that after you FOIL out a plus h quantity squared. You have to distribute this negative sign and make sure you get all your signs correct. And if you do so, you'll end up with a nice, quick, and easy limit. And it looks like this. So we end up with this as our limit. We're still having the limit as h approaches 0 after doing all of the distributing and all of the multiplying and expanding out. It's not too bad. We have negative h squared minus 2 times a times h minus 4h all over h. Still, if you plug in 0, you get 0 over 0, but that numerator is a lot nicer. Not only that, but our numerator all has the letter h, which is a good thing. That's going to allow me to factor out that letter h. And if I factor out the letter h, I'll be left with a negative h minus 2a minus 4 all over h. Now, what's really important is that this limit still equals 0, because if you recall on the last slide, it said that we want the slope to be horizontal, or the tangent line to be horizontal, which means the slope has to equal 0. So this limit still equals 0. So I should put that these are arrows, not equal. Each step along the way equals 0. Now my h's will reduce down, and so I end up with the limit as h approaches 0 of just negative h minus 2a minus 4. That's got to equal 0. Well, we evaluate a limit by plugging in the value of the limit. We plug in 0. If you plug in 0, you're left with another variable. When you plug in 0, you're left with negative 2a minus 4, and that has to equal 0 if we're going to be horizontal. We can do some quick algebra, add 4 to both sides, divide by negative 2, and that tells us that a has to equal negative 2. A is our x value, and so when the question asks where is the equation horizontal, where is the tangent line horizontal for this equation? The tangent line is going to be horizontal at x equals negative 2. If they asked us for a specific coordinate, then we would want to take that negative 2 and plug it in either way. But we've got the x value now, and we're good to go.